So parabola, I think you know about parabola. Parabola is a curve in which every point in the curve is equal to the distance of a point which is called focus and the line called directrix. So here so so here this is focus. Now let us consider parabola. Put the point which is focus in a normal plane and draw a line directrix. Now try to place the points which are equal in distance from both focus and directrix. Obviously this is the midpoint of both, because this is what the point which is equal in distance from the focus and directrix. So if we try to plot every point, then we can construct a parabola. So you know parabola, we have a line of symmetry which is perpendicular to directrix, and we can use a parabola in different applications. If we consider a parabola as a reflector, we can take an example of car headlamp. This is an example in our daily life, and this is what we know the equation, right? Y square equal to 4ax, and the parabola has the property which the rays coming from the focus reflects parallelly. That's what we can see in a headlamp of a car. When we are talking about a paraboloidal reflector antenna, we can place an antenna in the place of focus, so that we will see that it has high directivity. The paraboloidal reflector antenna is like this. We can place a feed or antenna at the place of focus, and we have a reflector here. It may be any normal type of reflector, and we have to select a type of antenna. So let us see why we are going for paraboloidal reflector antenna. We can use in some applications we cannot use normal type of antenna. So let's see. When it comes to satellite communication, the distance is so long. So we have to the signals coming from the satellite, we have to capture them. If we use a normal antenna, it can concentrate only on a small area. But in a paraboloidal reflector antenna, it has a large reflector, so that it can cover a large area, so that it can receive signals very easily. And we can see that in our homes, our TV dishes, where we can see, and we can use this in telephone and television signals, transmission between nearby cities, and satellite communications, and radar. We can use them as radar antennas to locate ships, aeroplanes, and guided missiles. So parabolic reflector antenna is generally used in the frequency range of 300 MHz to 300 GHz, which is nothing but microwave frequency range. Has less wavelengths. We have to design the size of the reflector depends on the wavelength. Obviously, the size of reflector must be more than the wavelength of the wave what we used for the communication. So next one. So what do you think? What type of antenna is better if we placed beside the reflector? So we cannot take any type of antenna, right? We don't need, if we take isotropic antenna, it radiates equally in all directions. So we cannot use no need to radiate in all directions. If we have to choose an antenna in such a way that it has to radiate maximum in only one particular direction. We can choose a horn antenna, or we can choose Agioda antenna, so that it can reflect maximum towards the reflector, so that the reflector reflects to the receiver. So as per basic, we just see the first null beam width and directivity of isotropic antenna in both situations, in circular, if it is circular aperture, and in rectangular aperture. So these are the formulas. So next one, let us talk about spillover. What is spillover? Spillover is just if the antenna does not capable of radiating maximum in one particular direction. If the reflector cannot capture the maximum radiation from the antenna, that's what spillover. We can see some of the desired rays are scattered in different directions at which the reflector cannot capture them. That's what the spillover is. So that's the reason why we are not choosing isotropic antenna as a feed. So more inventions came into picture, and Cassegrain he developed a type of reflector which is Cassegrain feed. So not reflector, it's a type of system that is what we call as Cassegrain feed. Let us see here. He used to place, we generally place the antenna here. This is normal type of thing, and here in Cassegrain we used to place an antenna at the vertex of the reflector, and here he used to put another reflector. This is what we call as hyperboloid secondary reflector. So the radiation coming from the feed, the radiation coming from the antenna which is at the vertex reflects in the secondary reflector and reflects back to the primary reflector, which in turn reflects parallelly to the receiver. So this is what by using this type of feed, we just overcome the spillover disadvantage. So this is what the major thing, and we can use it in many applications. So let us see what are the advantages of Cassegrain feed. Why we are going for Cassegrain design? As I said, reduction in spillover and ability to get an equivalent focal length much greater than the physical focal length. So this is what the thing. Well, the rays actually in a parabola concept, the rays actually coming from the focus itself only reflects parallelly. But here it's not coming from the focus, but it is reflecting parallelly. We can see that the both this reflector and this reflector, primary and secondary reflector, has common focus point. So the rays virtually appears to be coming from the focus, so that the rays reflects parallelly.